Hello everybody, and welcome to one of the best units ever called quadratics. You guys just watched a video in which you watch an NFL kicker. I'm going to circle that kicker in the middle of the screen. Kick a ball up into the air, and it formed this beautiful arc. We call this arc a parabola. And this is just another way to describe the graph of a quadratic function. What's beautiful about a parabola is that anytime you throw something up into the air and it comes back down, it makes the shape of a parabola. So in soccer, in football, in baseball, in softball, volleyball, anytime a ball goes up into the air, it makes that nice parabola arc. So if you notice this shape of the ball, it started by increasing. It reached a maximum point, and then it began decreasing back towards the ground. So increasing up to a maximum point, and then decreasing back down. This particular video is going to be all about the different parts of this parabola, which will help us make connections between the graph, the table, and the equation. So here are the notes that we are going to be taking. It might be helpful if you write this down in your notebook. Otherwise, I'll take a picture of the screen when I finish the notes, and you guys can use that if you like to. So the graph on the left is the graph of the parabola that we are going to be referring to in this video. So let's start on the right here, the upper right corner. And I'm going to draw in blue for this first part. So the first sentence says, the parabola changes direction at the vertex. So let's look at our parabola on the left. If we start on the left of the parabola, you can see that we're increasing. We reach a point, and then we start decreasing. So we start increasing. We reach our change of direction point, and then we start decreasing. This point at the top in blue is called our vertex. It's the point where your parabola changes direction. We write our vertex as a coordinate point. So if we want the point here, we're going to see that we went over to, if you look on our axis, -4 So 1, 2, 3, 4. And then we went up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our point is -4, 9. So on the right, in the upper right corner, this parabola's vertex is -4, 9. The next part I'm going to color in red. A parabola has a maximum when the graph has a high point. So if our graph, if you look on the right here, is open down, we can say our graph has a maximum. Our parabola has a minimum when the graph has a low point. So on the right, if our graph opens up, we have a low point, which we call our minimum. If we look at our parabola on the left, our parabola opens down, and it has at the very top a maximum point. This maximum point happens at the same point as our vertex, which was -4, 9. So we could say on the right again, this graph has a maximum at -4, 9. The next part I'm going to color in green. So we're still on the right side. The parabola crosses the x-axis. So if you look on the left at our graph, the x-axis is this axis, the horizontal one. So back to our notes, the parabola crosses the x-axis at the roots, also called the zeros, and most often called the x-intercepts. So the x-intercepts are where, if you look at our graph again on the left, it's where the x-axis and our graph, the purple parabola, cross each other. They cross each other at these 2 points shown in green. So this left one here on the bottom right corner, and this right one as well. Just like the vertex, we need to write down the coordinates for those points. The left point is at -7, 0, and the right one is at -1, 0. So for our notes on the right, this parabola's x-intercepts are -7, 0, and -1, 0. The last part of our notes, so on the bottom right, is the line of symmetry, which is the line through the middle that makes two equal parts. For example, if we drew a heart on the bottom right, the line of symmetry would go through the center so that the right part of the heart, if we fold it over this line, would exactly line up with the left side of the heart. Let's go back to our graph on the left. That would mean we draw a line right through the center of this parabola. Because if we folded the right side of our parabola over this line, it would match up perfectly with the left side of our parabola. We write this line as the equation of a line. So this is our line of symmetry. This line crosses our x-axis at -4. This point here. So we would write x equals -4. So in the bottom right corner, this parabola has a line of symmetry at x equals -4. At this time, you guys are going to download the next worksheet so you can practice this. I'll put a solution guide up as well after you finish the worksheet. Please submit it and ask any questions you have on the discussion tab on our Schoology website. I hope you guys are having a great day. Thanks for watching. Bye.